Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Counting Killers by Giannis. And here are the I don't know. That just came up to me. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. If a digits cannot repeat within a cage. So we can't have repeats within cages here. So we can't have, say, like a 6 here and then a 6 here. That would not be allowed because you don't have repeats within cages. And if a digit in a cage sums to n, if the digits in a cage sum to n, there are exactly n cages whose digits sum to n. So instead of digits being in circles, these are digits in cages, and it's the sum of that digits that matters. So, if the digits in a cage sum to n, yeah. So say this added up to 10 here. Then there would be 10 cages in this puzzle, which must add up to 10. So we could have like 7, 3 here, and then 4, 6 here. I don't know. 2, 1. No, that's right. 1, 2, and 6 adds up to 9. Sorry. So then we have to have 9 cages adding up to 9. So then we could have 3 and 6, I guess, and then 4 and 5. We could have 2, 4, and 3. But basically, it's something along those lines. 2 and 7. That would be 1, 2, 3, 4, 5. We would need 1, 2, 3, 4 more. 1, 8. No, there. 1, 8. And 1, 8. That would be valid, I think. We have 1, 2, 3, 4, 5, 6. No, that's 8. I guess 2, 6, and 1. So this would be valid because as I said, in these cages, the sum is all that matters. So if it adds whatever sum it adds up to, that sum, there must be exactly that sum of cages which sum up to that sum. Interesting. That's one. Let me just double check. That doesn't really matter, I guess. But 1, 2, 3, 4, 5, 6, 7, 8, 9 cages, all adding up to 9. So that is an example of how these cages work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. How many cages are there? That's the most important thing. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then we have 4 each here. So that's 22. Now the thing is, box 7 and box 9, let me just double check. We have 4, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Yep, 22. So, in these cages, in these boxes, specifically box 7 and box 9. Or box 7 and box 9. There are 4 cages all in the box. And they must sum to 45 because they contain all the cells in those boxes. Now the thing is, you cannot divide those boxes into an even set of digits. Huh. How does that work? Because the only thing I can think of. Oh, that's not true. You have to have. Okay, so you can't divide 45 by 4 evenly, right? So therefore, you can't have all of them be the same number of same sum, essentially, adding up. You could have had it if you don't have all the cells um, essentially accounted for, but you can't do it with 4 cells, 4 cages, all containing all the cells in that box. And only containing cells in those boxes, right? Because then all 40, we know the sum of those 4 cages has to be 45. So, how do we distinguish that then? Well, we need the two sums. There has to be only 2 sums. There can't be 3 sums. Because if you have 3 sums, the minimum you would have is it would have to be 3 plus 7, 1 and 2 together, 3 and 4 together, and then 5 and 6 together. So 3, 7. The problem is that doesn't. Then you have to have a repeat somewhere there, and that's not possible, right? Um, if you had 3 different sums adding up to 22, I think the minimum would have to be 6, 7, and then 9, right? For 3 digits, for 3 numbers. Um, but even that's a problem. Okay, so if you try to have 3 sums, the problem is the fourth cage would have to be a repeat of one of those other cages, which is not going to work because 45 minus 22 is 23. Therefore, it has to be 2 sums to add up to this. But the problem with that, okay, so 22. The problem with that is the 2 different sums must add up to 22. And then you have to have duplicates of one of those add up to, or both of those adding up to 23. That doesn't, okay, so then you could have 11, you can't have 11 and 11, right? Because those are duplicates of each other. Um, but if they that's the problem. It's if they add up to 22 as two separate sums, how are they going to add up to 23 if you just duplicate? You can't duplicate both of them because then you get another 22 and that's 44. But the problem is it's not duplicatable by a single sum twice. So that's not going to work either. I counted this right? We have 4 here, that's 8 cages. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Digits cannot repeat within a cage if the digits in a cage sum to n. There are exactly n cages whose digits sum to n. Ugh. Yeah, the problem. Okay, so the problem is you can't duplicate both sets twice, but you can't duplicate one set to add up to. You can't duplicate one sum twice then to add up to 23. How is that? How is that gonna work? Does that actually even work? If a digit's in a cage, sum to n. There are exactly n cages whose digits sum to n. Yeah, the problem is this is problematic because they must add up to 45. There are 22 cages though. So the two different sums have to add up to 22. Ugh. How does that work? Yeah, because all the different sums must sum to 22. That's a guaranteed. Because we only have 22 cages here. So if you had a sum adding up to 9, 9 cages, exactly 9 cages must sum to 9. If you have digits that sum up to 15, 15 cages must sum up to 15. But we only have 22, and that means the other 23 in these boxes, how are you going to get, what sums can you get to add up to 23? It can't be one sum twice because it's an odd number. And then you can't have both of them adding up because you know the different sums add up to only 22 at most. So that seems like it's a contradiction, unless I'm reading the rule set wrong. Normal Sudoku rules apply. Okay, digits cannot repeat within a cage. Okay, if the digits in a cage sum to n, there are exactly n cages whose digits. Yeah, this is just seems like it's fundamentally it can't work. If there are digits in a if the digits in a cage sum to n, there are exactly n cages whose digits sum to n. But there's only 22 cages. So we could work if it was 23. That would be fine. Or more. But 22 seems problematic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Oh. No. No, 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 no. Again, you can't have three different sums. If you had three different sums. Oh, wait, you could have three different sums. In fact, you have to have three different sums. Otherwise, it's not going to work. Okay. Yeah, you have to have, well, at least three different sums. Could be four, maybe, even. To add up a 22, though... Can you have three different sums? Oh. Well, you can't have two different sums. That's just not going to work. Because, again, if you have two different sums, the two sums must be in a box in these boxes here. And then they add up to 22. And then the remaining sum must sum up to 23. So that's not going to work. But maybe you could have like 8 times 3. So one of these sums is going to have to be times 3. And then you have another sum there. And then you have a different sum in another set. I think that's the only way it works. You can't have... Okay, obviously you can't have 4 cages all sum up to the same sum. So one of... And you can't have 2 and 2. Because that is equal to an even number. 2 times whatever number is always going to be even. And 45 is odd. So you're going to have 3 times a sum and a single sum. Does that work with the single sum and the 3 times the sum adding up to 22? Well, okay. 3 times 11... Okay, the high... Okay, 3 times 11 is not going to work. Because that's 33. 45 minus 33 is 12. Okay, so that's... Yeah, that's how we're going to have to break it down. So 11 or below for the 3 times cage is not going to work. Because 11 plus 12 is 23. And that's too big. 3 times 12 does work. Potentially. But then, so you have 3 times 12. That's 36. Plus 9. But then you need a cage adding up to 1. And none of those is possible. So 12 doesn't work. But we have something that actually functions okay. 13 times 3 is 39. 13 times 3 is 39. Plus 6 is 45. So you have 13 plus 6 is 19. 22 minus 6 is 3. So that could work. So you could have sums of 13, 6, and 3, adding up to 22. So let's write those down. We have 13, 6, and 3. 14. 14 times 3 is 42. And then you have 3. $14 and 3. Okay, I guess that could work. And then you have 22 minus 14 minus 3. So 22 minus 14 is 8, minus 3 is 5. Okay, so those are the combinations you can have for 8 and 9. Sorry, boxes 7 and 9 to work. Because again, you can't have it all 4 sums be the same sum. So you have to have guaranteed 2 different sums. You can't have 3 sums add up to that, to 45, because if you have 3 sums adding up to 45, multiples of those sums adding up to 45, you would have to have three different sums, and then the last sum would be 23, which is obviously too big. And then, so you have to have two specific sums in each box that is completely filled with cages. That's entirely filled with cages, and the cages don't go out. So that means you can't have a single sum in that. You can't have three sums or more. You have to have exactly two sums in each of those boxes. That means, and you can't have two of each, so it can't be four of one. It has to be three of one and one of the other. And we tried 11 and below. The problem is the sum of the individual sums up to greater than 22. For 12, the problem there is 12 times 3 is 36, plus 9 would add up to 45, but 12 plus 9 is 21, so the last remaining sum of a cage must be 1 in that instance. 15 doesn't work, obviously, because 15, you have three sums adding up to 15 and then one sum of 0, which can't work. So then we have 13, where we have 13 times 3 is 39, 45 minus 39 is 6. So the last remaining sum in that box is 6. And then the other sums that must sum up must be 3. Or we have 14, where the remaining sums must be 3. And then you have to have 5 as a sum that's not in those boxes. So these boxes must sum up to either 13, 6, and 3, or 14, 3. So there's in box 7 and not 8. Sorry, box 7 and box 9. You have either 13 and 6 as the sums, or 14 and 3 as the sums. The 13 and 14, obviously, the 6 and 3, the 6 could actually be 1, 2, 3 as a triplet. I was going to say the 6 and 3 obviously are the 2-cell cages, but that's not true. Interesting. Okay. Huh. So the interesting thing is... Oh, that's not true. I was thinking that there was a restriction on the 6 and 3 cages, but that's actually not true. If this is... So if you have 14 and 3, obviously this has to be the 14. So 14, 3, and 5 means 14 and 3 are the sums in box 7 and box 9. One of these is going to be 1 and 2 as a pair, which means none of these could be 1, 2 as a pair. So 1 and 2 would have to be there. And we have one of these three adding up to 1, 2. So we'd have to have... this adds up to 14. Two of these sets add up to 14. So it'd be 5 and 9 and 6 and 8. Oh, that doesn't work. Because since we only have two pairs here adding up to 14, one of these is going to be 5, 9, one of these is going to be 6, 8, but these also have to be 5, 9, and 6, 8 for that. But that would eliminate all possibilities in one of these cells for this cage, for these cages, when they have to have 5, 9, and 6, 8 there. Therefore, 14, 3, and 5 does not work, and it has to be 13, 6, and 3. So 13 and 6 are the sums in box 7 and box 9. So these two sums the 6 occurs only once in each box. The 13 occurs 3 times. And we know, okay, so we know 2 out of 3 of these at least have to be summing up to 13. But we can't have all 3 of these add up to 13. Because one of these is, so again, in box 7 and in box 9, only one cage adds up to 6. 3 of the cages at least, or 3 of the cages must add up to 13. 1 adds up to 6. So you're guaranteed one of these is a set adding up to 13. You can't have all 3 of these cells here in box 7 be adding up to 13 because that gives all the possibilities of 4, 9, 5, 8, and 6, 7 in these cells. But the problem with that then is that these cells right, okay. So, what does that mean? Again, if you have all 3 of these sets adding up to 13, there's going to have to be a set here that adds up to 13 and would eliminate the one of these sets adding up to 13 completely, right? Because if this is say this is 4, 9, 5, 8, and 6, 7, and this is 6, 7 as a pair, that means this can't be 6, 7 here. So, because of that, you cannot have all 3 of these add up to 13. One of these is going to have to add up to 6. We don't know which. And this must add up to 13. So since it's 6 here, the only possibilities adding up to 6 are 1 and 5, or 2 and 4. And we have 2 more pairs adding up to 13. The pairs adding up to 13 are 4, 9, 5, 8, and 6, 7. So you're guaranteed 6, 7 must be one of these sets of 3 cells. Because the 6 is 1, 5, or 2, 4. So we're losing a 4 or a 5 in that set, and we have to have 2 more cages adding up to 13. So we're losing either 4, 9, or 5, 8, and we have to have that other one with the 6, 7 be the 13 cages. So that means we have a guaranteed 3 here. And to add up to 13, if we lose, it's 1, 9, or 2, 8. So this is 3 with 1, 9, or 2, 8 there. One of these is 1, 5, or 2, 4, and the other one 6, 7, and then we have a 4, 9, or 5, 8 as these. Therefore, 3 can't be any of these. 3 can't be any of these cages, so 3 has to be one of these 2. And this also must be 3 with 1, 9, or 2, 8. We have a guaranteed 6, 7 here. So 6, 7 as a pair cannot add up, cannot be either of these cages, because that would eliminate all possibilities for a 6, 9, 6, 7 to be in one of these cells here or one of these cells here, which means 6, 7 then couldn't be in the cage here. So 6, 7 has to be here. And then this is a combination of 1, 8 and 4, 2, 4. So 6, 7 is one of these threes. No, 6, 7. Okay, whatever. I don't get that. I don't get that reference anyways. 3 cannot be here. So that means 4 and 5 must appear in row 7 in box 8. And then the last one's 1, 2, 8, or 9. Okay. Well, now that's interesting. So we have 13, 6, and 3s are the sums. So there's gotta be some that are 1, 2 as a pair. And it could be here, it could be here, or here. It could be here, 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 or here. Hmm. We have 13 13s. We 6s could be 1, 2, and 3 technically. So this is also 1, 2, 4, 5, 8, and 9. Can we ever have a 9 here? 9 and 4 at minimum add up to 13 already. So 9 cannot be here. 9 could be here though. 8 and 4 do add up to 13 potentially. This must always add up to 13. So let's color the 13s as a special color. Let's make it, I don't know. We'll make 3 the low. I'll make it red, I guess. This is 13. 4 plus 1 can never, with a different digit, add up to 6. And we have to have a 4 here at least. It can't be, it cannot be 4 and 5. 4 and 5 must sum to 13 with another digit, but that other digit, 13 minus 9 minus 4 or 5, which is 9, is 4. So that would have a repeat, if that were the case. Therefore, this is guaranteed to be 4 or 5 here. And this is 4 or 5 with another digit, adding up to 13 here. So this is 13. This is 13, because you can't have 1, 2, and 3 as a triplet there. Technically, you could have 1, 2, 3 there as a triplet. No, you can't. If you try to have 1, 2, 3 as a triplet here, then this is at minimum 4, 5, and 6, which is 15, which is too large. So this also must add up to 13, because it can't add up to 6 or 3. Hmm. Okay. So whichever pair is here, that adds up to 13. Sorry, whatever pair is here that adds up to 6 means the other pair must add up to 6 here. We'll mark one pair as blue and one as yellow. So whichever ones is yellow here, one of them is here, and then the other one has to be in one of these digits, adding up to 13. Whichever low is here, one of the lows is one of these, is the ones adding up to 13 there. Okay. This adds up to 13 without 4 or 5. What are the possibilities there? Without 4 or 5, we have 139. 139 adds up to 13. Obviously, no 148, no 157. Two, 3, 8 adds up to 13. No 247, no 256. So we have to have a 3 here. And this is 139 or 238 also. Interesting. Okay. That's interesting. Okay. So where are 6 and 7 remaining in this box? One of them has to be in the cage here, and then you can't have both of them here. They already add up to 13 there. So one of them has to be there. Well, 4 and 6 at minimum is 10. Which means the digit here must be the other digit here must be 1 through 3. Obviously can't be 3, so the 1 or 2 has to be here. Which means this cannot be 1 or 2. One of them's going to be used up here, and one of them's going to be used up here. And because 4 and 6 already is 10. 13 minus 10 is 1, 2, or 3. But we can't have a 3 here because we need it for this cage here. So 1 and 2 is here, 1 and 2 is here, which means this cannot be 1 or 2, which means this is 4, 5, 8 as a triplet, which eliminates 4, 5, 8 in the rest of the row. So this cannot be 2 and 8, it's 1, 3, 9 here. That means this cannot be 1, 3, or 9, or 8, so this must be 2, which makes this 2, 3, and 8 here. And this is 8, so this can't be 2, 3, 8 here. It's 1, 3, 9, adding up to 13. 8 cannot add up with 5 with another digit to add up to 13. So this must be 4, 8, and 1. That means this can't be 4, it's 5. There's no 1 here because of 1 in the column. So 1 has to be here to add up to 13 with the 3 and 9. And it has to be 2, 5, and 6, adding up to 13, which makes this 7. So this cannot be a 1, 5 pair adding up to 5. So this must be the 1, 5 pair adding up to 6. So this must be the 1, 5 pair here. That leaves this as a 4, 9 pair there. That eliminates 4, 9 in the rest of the row, so no 9 here. It's 3, no 3 here. It's 9. 3 eliminates 3 here, so it's 8, which makes that 3. These pairs of digits, we have to have 4 in one of these digits here, which means 2 has to be adding up with that to add up to 6. Therefore, this can't be 2 here. It's 6, which makes this not 6. It's 2. This has to be 4, 6, and 8. The 6 adds up with the 7 to add up to 13. The 8 adds up with the 5 to add up to 13 there. And that is that. Okay. This can't be 1, 2. So we know this is 13. This adds up to 13. This is also adding up to 13. This adds up to 6, which will be as green. Oh, it should be yellow and green, but anyways. So we have 1, 2, 3, 4, 5, 6, 7 cages adding up to 13. Remaining digits of column 4. We have 1, 3, 4, 7, 8, 9. No ones here because of ones in the box. Okay. What does this add up to? So this cannot add up to 3, and it cannot add up to 6 because we don't have 2 available, we don't have 5 available. That eliminates 1, 2, 1, 5, and 2, 4 as possibilities. So this must add up to 13, which cannot be 1 and 3. It has to be 4 and 9 as a pair. That eliminates 4 and 9 in the rest of the column. Well, this is a 3, 7, 8 triplet now, which eliminates 3, 7, 8 in the rest of the column. So this is 1. 1 and another digit never add up to 13. So this is either 3 or 6. We're not sure which. This cannot add up to 3 or 6 because 4, 9 is in the box, 1 is in the column, so 1, 2 is eliminated, 1, 5 is eliminated, and 2, 4 are eliminated, which means this also adds up to 13. Cannot be 6, 7, it cannot be 4, 9, so it has to be 5 and 8, which eliminates 5, 8 in the rest of the column, so no 8 here, it's 4, which means this can't be 4, that's 8. Okay. Remaining digits of column. So how many do we have? 1, 2, 3, 4, 5, 6, 7. So we have 8 and 9. We have 9, right, because we have how many cages here? 8. 4 plus 2 times 2 is 8, plus 3 is 11. And only 2 of these add up to 6. So that's 9 cages, which add up to 13 already. This is 10, that's 11. So we need 2 more cages. Remaining digits of column 5. We have, well, 3, 7, 8 cannot be here. So 3 can't be here because of 3, 7, 8 in the triplet in the box. So 3 has to be there. That leaves this as what, 2, 5, and 6? Yes. Remaining digits of box 2, we have 2, 6, and 7. Excuse me. Remaining digits of column 6 are 4 and 5. Not 4, no, that doesn't. Oh, this can't be 2, 5, and 6. It's 2, 6, and 9. 2, 6, and 9. Okay. Now this is interesting. This cannot add up to 3, obviously. So it could be medium, but if it's medium, it's 2 and 4. If it's high, which is 13, it must be 9 and 4. So either way, if this adds up to 13 or 6, this must be 4. So since this is 4, this is 5. And this is with 2 or 9. This 5 could be with 1 here. It cannot be with 8 here because of 8 in the column. So this has to be 5 and 1, which is medium. And this is either high or it's medium. We're not sure. So we have 3 mediums, 3 6s. 13, 6, 3. This cannot be 2 and 1 anymore. But it could be still medium, 2 and 4. So this could be medium or it's high. And if it's 2, then it's medium, and that's a 4. If it's high, it has to be 6, 7 as a pair. And either of those work. This can be either 1 and 2, or 1 and 5, adding up to 6. 3 or 6. This could be 3, 1, 2, adding up to 6, or it adds up to 13. So this is medium or high. Remaining digits of column 7. We have 4, 5, 6, 7, 9. No 4 here because of 4 in the row. We know 1 has to be one of these 3 digits. That's fine. One cannot be here. One cannot be there. Same with 3. 3 can't be here, and 3 can't be there. 3. Interestingly enough. So 3 cannot be in any cage. That's 2 cells. It has to add up to either 3, 6, or 13. 3 in another digit, non-zero digit, cannot add up to 3. 3 and 3 add up to 6, so obviously that doesn't work because you can't have repeats in cage. And 3 plus 10 adds up to 13. So 3 can never be in a 2-cell cage. That's interesting. So 3 cannot be here. 3 can't be here, so 3 has to be one of these 2 digits. That means 3 has to be one of these 3 digits here. 1 has to be one of these 4 digits. 1 can be only in a cage with 1 and 5. Or 1 and 2. 1 and 2 could work too. We don't know about 2. We need a 1, 2 pair somewhere. Well, 1 out of these 2 is 1 or 2. We need 3 1s and 2s. So 1 out of these 2 is 1 or 2. This can't be 1 or 2. So this has to be 1 or 2, and this has to be 1 or 2 because we don't have any other cell cages that add up to 3. So this has to be 1 and 2 and is low. This must be 1 and 2 and is low because there's no other combinations. Therefore, this must be 1 and 2 there. This cannot add up to 6, so it must be 13 because we don't have 1 or 2 available anymore there. One of these 2 is 1 or 2, and this has to be a 1, 2 pair, which eliminates 1, 2 in the rest of the column. So no 1 there, it's 5. No 5 there, it's 1. Okay. So we have 12 13 cells here. We have to have 1 more. Well, this can't add up to 6 anymore because of the 1, 2 pair in the box and the 1 in the column. So this has to add up to 13. And that's 1, 2, 3, 4. These are, hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that's 13 cells adding up to 13. Therefore, this cannot be. This must be not adding up to 13, and this must not be adding up to 13. So this is 4 and 2. That means this can't be 2 here, no 2 here. This must be 2 and 4. That means this can't be 2, so that's 1, which makes that 2. No 2's here. One of these two must be 5. This can't be 2 and 4. So this adds up to 13 and is 4, 8. No 1 here. Four eliminates 4 in the rest of this column. This adds up to 13 without a 1 or a 2 available. So it has to be 3, 4, and 6. The 1 or 2 are not available here, and it's not available here because of the 1, 2 in the box here and the 1, 2 in the row here. So it has to be 3, 4, and 6. So this must be the 3. This can't be 4 because of 4 in the box, so this is 6, and that's 4. That eliminates 6 in the rest of this box and column. No 6 there, it's 7 and 6. 4 eliminates 4 here, so it's 9 and 4. Okay. So then one of these, we have 1, 2, 3, 4 cell cages adding up to 6. We have 1 here, and then we have 1 here. So this is blue or green. One of these is a 2. If this is 1 and 2, to add up to 6 would be 5 and 1. So 1 either way has to be here, I think. And then if this is 1 and 5, this has to be 2, 1, which means 1 would have to be there also. So this is 1, 2, and 5. 1 eliminates 1 in the rest of this column. So this is 3, 9 as a pair, which means this can't be 3 or 9. It's 1. Okay. This 2, 5 pair eliminates 2 and 5 in the rest of the row. No 5 there. Remaining digits of column 9 are 2, 5, and 8, but 2 cannot appear in either of these cells because of 2's in the row, so 2 has to be there. That leaves us as a 5, 8 pair. 4 eliminates 4 here, so that's 9 and 4. Remaining digits of row 1 are 3, 6, and 7. That eliminates 3, 6, and 7 in the rest of the box, so we have a 2, 5 pair in the rest of the box. That means where's 4? 4 cannot be here because of 4 in the row, so 4 has to be there. And that leaves an 8, 9 pair remaining in row 2. That eliminates 8, 9 in the rest of the row, so no 8 or 9 there. It's 5, no 5 there, it's 8. 8 eliminates 8 there, so it's 5, which means this can't be 5, that's 8. 5 eliminates 5 in the rest of the box, and this 8, 9 pair eliminates 9 in the rest of this row. So this is 7, that's 9. 7 eliminates 7 here, so it's 6 and 7. That leaves this as an 8. Remaining digits, this can't be 7 or 9 because of 7 and 9 in the column. Remaining digits for column 8 are 3, 7, 9. Okay. This adds up to 13, again, without 1 and 2 available. This can't be 1 or 2 because of 1 or 2 in the column. This can't be 1 or 2 because of 1 or 2 in the box. So this must be, again, 3, 4, and 6. So this is 3, with this being 4, 6 as a pair. That eliminates 4, 6 in the rest of the column. So this can't be 4, 6, it's 8. 8 and 5 add up to 13. That eliminates 8 and 5 here, so this is 6 and 7. That means this must add up to 6, and it has to be 2 and 4. That eliminates 2 in the rest of the column, so it's 5. This can't be 5, so it's 2. So this is the low now here. This is not low, it's 6. We have 6 cages adding up to 6, 13 cages adding up to 13, and 3 cages adding up to 3. So the rest is just normal Sudoku. 3 eliminates 3 in the rest of this row here. This can't be 8 because of 8 in the, 3 in the column here. 8 eliminates 8 in the rest of the row, so that's 7, which makes that 8. 4, 6, 8 eliminates 8 in the rest of the column, so that's 9 and 8. 6 and 7 eliminates 6, 7 in the rest of the column, so that's 3. So no more 3 here. That's 3 in the corner. We celebrate because we're close to solving it. 3 eliminates 3 in the column, so it's 9 and 3. That leaves this as a 5. 5 eliminates 5 in the rest of the row, so it's 6 and 5. 6 eliminates 6 in the row, so it's 9 and 6. 6 also eliminates 6 here, so it's 4 and 6 there. 6 eliminates 6 in the column, so it's 7 and 6 there. No 3 or 9 because of 3 or 9 in the row here, so that's 7. That leaves the remaining digit in row 6 as an 8. Remaining digits in column 2 are 7 and 9, and this can't be 7 because of 7 in the row. So that's 9 and 7. 7 and 9 eliminates 7 and 9 here, so it's 3. No 3 or 7 here, it's 9, which leaves this as a 3. And that's the solution. Yeah, here the break-in was... It took a while for my brain to figure out the break-in. I was making too many assumptions there. But obviously it was leading to a contradiction, so there was obviously something problematic there. But once I really thoroughly thought it through, it wasn't too bad. And... yeah. I don't know. The break-in, yeah, the break-in is probably hard. And then the rest of the logic I felt wasn't that bad. But execution-wise, execution-wise and thought-wise, it took a while to think about the break-in. So, but I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.